Now, we're going to start our discussion of what we call polar coordinates. Okay? Now, polar coordinates means graphing on a polar axis, okay, or a polar graph, as we see here below, okay? And of course, as you can see, okay, the graph is marked off in increments, degree increments, could be in degrees or radians, okay, doesn't make much of a difference, and at radial distances from the center, okay? The center here is known as the pole, okay? Points are plotted relative to the pole and relative to what we call the polar axes, okay? Now, the polar axis is, okay, if you were to think to superimpose a x and y axes over top of this, okay, the polar axis would be the positive half of the x-axis, okay? So the polar axis is from the pole due east, if you will, okay? The pole due east, okay? It is, so every point that we plot is going to be in terms of a radial distance from the center and an angle sweep, okay, relative to that polar axis, okay? By convention, the center is 0. It's not 0, 0, although it could be 0, 0, but we could see once we start plotting points that it could be 0 any angle. It could be 0, 90. It could be 0, 45. It could be 0, you know, negative 3 pi over 2, okay? So as we said, all points are plotted relative to the pole as a radial distance from the pole and at an angle sweep, okay, from this polar axis extending as if it were the positive half of the x-axis, okay? Just as we've seen before, angles swept in the counterclockwise rotation are going to have a negative angle sweep. Angles swept in the positive direction are having a counterclockwise. Angles swept in the clockwise are negative angles. Okay, by convention that we saw previously. Okay, this point as plotted is at all points. Okay, are plotted as r comma theta. R comma theta. That's a radial distance from the center at an angle sweep. In this case, we're going with radians. It doesn't much matter. Preferably, we go with radians. But 5 pi over 6, of course, is 5 radial units out. So count out 5 rings. Each one have 1 unit ring. Okay, and it looks like maybe I counted out wrong. 1, 2, 3, 4, 5, 6. That's actually at 6. So, and then the angle sweep of pi over 6 or 30 degrees. Okay. Now, okay, let's plot a couple other points, all right? So here we're going to plot 2 pi over 3. 2 pi over 3, otherwise known as 120 degrees, is going to be on this radial length, okay, at a distance of 3 units out, okay? So there it is, 1, 2, 3 units out on the 120 degree radial sweep on the third ring out, and 4 pi over 2 is going to plot, okay, 4 units out, 4 rings out, and a 90 degree sweep up, okay? So that's how we plot points, okay? However, we're going to see that that point, any point, could be named in any number of different ways, okay? Here's our point P, which previously was identified as 5 pi over 6. But that point's name is not unique, because perhaps we got there by going through a different sweep, okay? So a sweep of pi over 6 lands us right here at 30 degrees, but there again, it could be 1 full revolution and pi over 6, so 13 pi over 6 likewise names that point. Or perhaps I could do a swing in the clockwise direction, which would be the swing in the clockwise direction would be with a negative angle of rotation, naming that as 5 negative 11 pi over 6. And indeed, there are infinitely many more ways in which we could name that point. So unlike X and Y coordinate systems, okay, polar coordinates do not have unique names. Do not have unique names. Now somebody might ask, well, what if is it possible? Is it possible, even possible, to have a negative radius? Well, in effect it is, okay? So we're going to see what happens if we have to plot negative radii points. So I'm going to say I want to plot this point -9, 5 pi over 6. -9, 5 pi over 6. Now, for the moment, I'm just going to discard the fact that this is negative. I'm going to say I'm going to be on the 9th ring out at 5 pi over 6, which should be at this point right here, okay? But what happens, okay, and here's that point right there. Here's the point 9, 5 pi over 6. Plotting -9, 5 pi over 6 does the same angle rotation, but then it projects it backwards. The negative r value actually projects it backwards so that we plot here 9, 5 pi over 6, then we project it backwards, which means we add another 180 degrees to it so that it ends up here at this location. So this point A is actually the location of -9, 5 pi over 6, okay, -9, 5 pi over 6, okay, but there again, that point could have infinitely many names as well. So here's what we're going to say in general, okay? So a point having a negative r value, a polar point with a negative r value, is the same as that value, as that point with a positive r value, and then sweeping it through another 180 degrees or another pi radians, okay? So -9, 5 pi over 6 is the same as the point, okay, 9, add pi over 6 gets you 11 pi over 6, okay? It's the same location. So that was our introduction to plotting points on polar coordinates, okay? So we'll stop it at that, and then we'll come back in the next video and start talking about some symmetry. There we go.